Welcome back to Ajad ICS Academy, Chandra Layout, Bengaluru. Fine. This video is in continuation of part 1 and this is part 2. In the previous one, I tried to concentrate to solve the maximum number of questions which are based on number system. Now, I will move on to the non-number based questions, arithmetic and mental ability and aptitude based. We shall start that is, let's see that. 14 black balls, 14 black, 20 blue, 20 blue, 26 green, 28 yellow, 38 red, 54 white balls, So there are 6 colors are there: 14 black, 20 blue, 26 green, 28 yellow, 38 red and 54 white. Let us see that is what is the total number of balls in the box. 4 plus 6, 10, 18, 26, 30. So 3 carry again here. 4, 6 plus 2, 8 plus 2, 10, 13 plus 5, 8. There are totally 186 balls are in the box, which represents all 6 colors: black, blue, green, yellow, red and white. Now see the statement. Which statement will qualify for according to the question? And here statement 1 says the smallest number n such that any n balls drawn from the box randomly must contain one full group, at least one color is 175. At least one color is 175. One full group of at least one color. This is the clue words question. One full group of at least one color each. One full group. In a group, see how many colors are there? There are 6 colors: black, blue, green, yellow, red. It means one full group of at least one color each, that is equal to 6. Right, is 175. That is equals to, he says that is 175. And totally you can see that number of balls is 180, assuming that is the one full group. In the sense we have been drawing all the balls from the boxes, we don't get one like that. For example, 14 minus 1, 20 minus 1, 26 minus 1, 28 minus 1, like you can say that 14 minus 1, 13, 20 minus 1, 19, 26 minus 1, 28 minus 1, 38 minus 1, 54 minus 1. So one we don't get that group, that is. So 180 total is available. How many? What is the size? That is a 6. 6 means what? 174. These balls has been withdrawn from the box. We have drawn 174 balls. But we need to get that group, that 6 balls group is required. The next attempt is definitely one more attempt is required. That is 175. This is the 175 answer definitely. And statement 1 will suffice the answer, right? And let us come to the statement 2. The smallest number m such that any m balls drawn from the box randomly, it must contain at least one ball of each color. Again, see that here This is the statement 1. Definitely this is yes. This will qualify. And statement 2, you can see here. And what is the total size is a 180. And here at least one ball of each color. One ball of each color. Maybe the small, that we say that at least, and smallest number. You can say again is the smallest number. What is the smallest number of each color? 14. Let us take minus 14 equals 180 minus 14 is 166, and the next attempt is required. So 167, and definitely this statement also will suffice to answer the question, and this is also right. And here it means both 1 and 2. Both 1 and 2. Right here. Both 1 and 2. Option C. We'll move to the next question. Consider the following, including the question and the statements. Including the question and statements. There are 5 members A, B, C, D, E in a family. There are 5 members A, B, C, D, E in a family. It's a family of 5 people. Question: what is the relation of E to B? What is the relation of E to B? Like E to B. This is the question we need to answer. Now what data is provided? Let's check that. We need to know what is the relation of E to B. Right. Now question is taken here and say the statement 1, 2, 3, 4. There are 4 statements are there. Statement 1, statement 2, statement 3, statement 4. And here you can see like you can see which of the following is correct in respect of the above question and statement. I think these sequences need to be checked. These statements need to be checked. Like all 4, let's see this last all 4 statements are not sufficient or together sufficient. Let's see and see these 2 things are required. First let us see the option A. Here in the option A, statement 1, statement 2 and statement 3 are sufficient to answer the question. Statement 1, 2 and 3. The first 3 statements, let us take that. First 3 statements is what? First statement 1 says A and B are married. A and B are married. I'll put like this. A and B are married because they are the couple. That's why I put the forward arrow and backward arrow. So these 2 are the husband and wife. Who is husband, who is wife is not known to us, since the gender is not known. Once we know the gender, we can determine. But they are the couple. These 2 are the couple here. And statement 1 is taken now. Right. And statement 2, and we need to E to B. B is there, but E has not come here. Let's see that. Another statement 2. Statement 2 is what? D is the father of C. Statement 2 here, because statement 1 is taken, statement 2. Statement 2 says what? D is the father of C. 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 This is the plus. But gender of C is not known to us. Lights. D is the father of C. Do we see any relation between E to B? B is there. E has not come. Right. And see that next we are trying with this one. Okay. And next 3. Statement 3. What is statement 3 says? E is D's son. E is D's son. D's son like this. This is E is D's son. Son is the son, like is a male, like that. D is D's son. Now, and see the relation. Okay, all the state from option A, all the 3 statements are taken to solve the question. But what is to see? E to B. B is here. E is here. There is no relation between E and B. Definitely, this will not suffice. Right. So A is not correct. Then let's come to the B. Statement 1, 3 and 4. Statement 1, 3 and 4. Statement 1. Statement 1 is what? Right. Statement 3 is what? Statement 3 says E is D's son. E is D's son. Like E. Statement 1. This is the statement 1. And statement 3 says is what here? E is D's son. E is D's son. Like that. E. But see that we can see the B and E, again is the same thing. Again you can see that here statement 4, A and C are sisters. A and C are sisters. And where do we write A and C are sisters? It means A and C are sisters. A and C are sisters. It means this is gender is not known here now. Both are sisters. And we want to establish the relation E to B. E is here, B is still we don't get. Even this is also not suffice. And let's see. Option C. All 4 statements together are sufficient. All 4 statements of together are sufficient. What are the all 4 statements? One is this one. Statement 2 says what? D is the father of C. D is the father of C. D is the father. You can see C and D are statement A and C are sisters. A and C are sisters. Right. E is D's son. Okay. And this we have to align. This is C is very much here, and C E. This is A B. Right. And so we want to know the relationship at E to B. Where is he? You can say D. Right. And now we can see E to B relationship can be definitely established. So to answer this question, we need to use all the 4 statements are sufficient to answer the question. So this is the C. Option C is the right one. Fine. See this question. ABCD is a square. ABCD is a square. Right. 1 point on each of AB, 1 point AB and CD, 1 point on each of AB and CD, and 2 distinct points on each of BC and DA, BC and DA, and 2 distinct points here and here like this are chosen. How many distinct triangles can be drawn using any 3 points? Because these are the points. Like point you can say like P, Q or S, T, U. These are the points. How many distinct triangles can be drawn using any 3 points as vertices out of these 6 points? How many points are there? 1, 2, 3, 4, 5, 6. Number of points is what? Number of points. Number of points is 6. And it says that is how many distinct triangles can be drawn using any 3 points. So triangles which requires what? Any 3 points. Any 3 points. Any 3 points out of 6 points. As vertices out of 6 points. That total number of points are what? 6. And how many distinct triangles can be drawn using any 3 points? It means you can take PQ also you can take. For example, see that point P. I'm trying to explain, but again this is a permutation combination. PQ, or you can, no, you will not get a triangle. PQ, which triangle you can say? PQ, like you can take. PQ, like that. So PUQ, PUQ 1. and P, Q, R, like that. P, Q, R, because like this how many combinations is possible. So definitely we can, let us see that solving, right. Now we can see 6 formula is what? It's a selection that's chosen, right. So 6, C and 3, 6C3 equals to what? 6 factorial by 3 factorial into 6 minus 3 factorial. 6 factorial is what? 6 into 5 into 4 into 3 into 2 into 1 whole divided by, and 3 into 2 into 1 into 3 into 2 into 1. So this gets cancelled, and see now 3 into 2, 6 gets cancelled, 5 into 4, 5 into 4 is 20 is the option. So option C. Option C is the answer. Now see now this question. Here percentage is written. Percentage is not the correct one. What is the thing here? Like P plus C all divided by P minus C. Right. 2PC can be right. Which of the statements given above are correct? Can be even. See that. Can be. Can be refers to what? Possibility. Can be refers to a possibility. Can be refers to possible. How many? You can see any possibilities. No, question is not how many possibilities. Is there a possibility? It may be. It may not be. Let's check that. And P plus C, primary number. You can see for respect P. P is a prime number. See, like here refers to P is the prime number. P is a prime, and C is C is composite number. Composite number. Let's say primary number plus combination number. Let us take any prime number. Let us take any prime number let us take 5 plus like 9 is thing all divided by P minus C, or difference between 9 minus 5 is what? And see that 14 by 4, yes, it will divide that numbers, no? Right. Let us take another example. This will qualify, right? And even you can see that prime number 2 plus composite number, let us take 4, first composite number, and 4 minus 2, difference of the number, this is 6 minus 2, and you will get 3. 3 is, of course, this is an odd number, it's not an even number. Let us take some other number. Any possibilities can be done here, and 7 prime number, this is, plus combination composite number 9 will get difference is what? 9 minus 7, so this is 16, this is 2, definitely this is 8. So definitely this is possible. This can be even. It satisfies the rule. It means now definitely this is statement 1 is satisfies the requirements. Now let us come to the statement 2. 2P plus C. So 2P plus C, 2 into prime number plus combination. Let us take the 2 into 2P plus C. In the sense 2, let us take prime number can be 2, composite number 4, let's see. 2 into 2, 4 plus 8 is can be odd disease, that is, because this is an even number. This is even. Let us check other numbers. Okay, this doesn't suit here. Next we can say a primary number you can take 2 into 3 plus 4 you can take 6 10, even this is also even, let us take like that. And 2 into 2 into 3 plus composite number is 9, 6, 9, 15. Yeah, this is odd. It satisfies this is. Okay, this also can be, there is a possibility. It means this is statement 2 is a possibility for that. What is asked in the question. Now, third statement, PC, primary number into composite number, can be odd. Primary number like 2 into composite number is 8. This is even. Let us check other numbers. Okay, but any number is multiplied by 2, that is an even number. Let us take other odd primary number 3 multiplied by 9. This is 27. This is odd number. Yes, there is a possibility here, and this also satisfies the rule. And what is the option? All statements 1, 2, 3 satisfies the question. And 1, 2, 3 option. This is the option D. Fine. Let us come to this question. 125 identical cubes are arranged in the form of cubical block. How many cubes? How many cubes surrounded by other cubes from each side? Let's see here. Now we can see this is the question here, and options are the A, B, C, D is 27, 25, 21 and 18. Yes, you can see here. And what is the 125? 125 cubes, it means 5 cube. This is equal to n cube, right? Then n is equals to 5. And which also no face. No face is equals to 5 minus 2 whole cube. Then 3 cube. Then 27 is the right option. So, ABC working independently can do a piece of work in 8, 16 and 12 days respectively. ABC working independently can do a piece of work in 8, 16 and 12 days respectively. See, this is the time and work. This question is from time and work. A can complete the work. A alone can do a work in 8 days. And B alone in 16 days. And C alone can do it in 12 days respectively. A alone works on Monday. A always works on Monday. B alone works on Tuesday. B alone works on Tuesday. And C alone works on Wednesday. A alone again works on Thursday. A again comes on Thursday. And so on. Again is second cycle start. But here A, B, C, there are 3 people. Each person takes different number of days to finish the work on their own. But they don't do work together. They work on different days on their own, alone. See, A works on Monday, B works on Tuesday and followed by C works on Wednesday. And again another cycle start. A works on Thursday, B works on Friday and C works on Saturday, like this. Again A works on Sunday and B works on Monday, C works on Tuesday and so on. This is the thing. Now we understood. Fine. Now what is being asked in the question? A works B and C, right. Consider the following statements. Now statement 1 and statement 2. Statement 1 says what? The work will be finished on Thursday. The work will be finished in 10 days. Which of the above statement is or correct? Is statement 1 correct? 2 correct? Both 1 and 2 is required to answer the question. Neither 1 nor 2. So right. Now we have to work it out now. So how to do it now? Because we do not know. Because A is a different days, B is a different number of days, C is a different number of days. Let's see 1 day work of A, 1 day work of B, 1 day work of C. 1 day work total ABC 1 day work is what? 1 day work of A 1 by 8, 1 day work of B is 1 by 16, 1 day work of C is 1 by 12. Go to the LCM. What is higher number here? Higher number is 16. 16 can be divisible by 8. Let us not 8 into the consideration. 16 and 12. What is the LCM of 16 and 12? 16 and 12 LCM is 16 multiples of 2, 32. 32 cannot be divisible by 12. Let's move on. 32, 16 into 3, 48. 48 can be divisible by 12. So let LCM can be 48. 48 by 8 is 6. 6 into 1, 6. 48 by 16 is 3. 48 by 12, 4. And now you can see 6 plus 3 is 9. 9 plus 4 is 13. 13 by 48. So this is all. All three take 1 day work is 13 by 4. 1 day work of A plus B plus C. A, B, C. 1 day work of A plus B plus C is 13 by 48. But how many days they are working like that? Now let us see. Here 13 is the 1 day work of ABC. How many the combinations will happen? 13 into 3. 13 into 3 is 39. 39 by 48. Here 3 timetable. A will work for 3 days. 13 into 3 here. Therefore 13 into 3 equals A's work is 3 days. A's work is 3 days. 3 days. And B's work is 3 days. B's work is 3 days. And C's work is 3 days. So A will work for 3 days, B will work for 3 days, and C also will work for 3 days. Now let us see here. And A comes on. What is now 13 by 39? 39 by 48 total work. And total work concept is 1 minus 13 by 39 by 48. 48. Remainder is what? 9 by 48. 48 minus 39. Remainder is 9. 49 by 48 is a remainder. This work is done by, because all three will work for 3 days. So it means what? A will work for 3 Monday and Tuesday. B will come. C will come. Again A 3 days will work. B 3 days will work. C Thursday will work like this. So now the 9 days work is already there. Now 9 days work is already there. That is a 9. 48. If the 9 by 48 is less than 1, first again who will come? A will come. Minus. What is the 1 day work of A? 1 by 8. Again go to the LCM. 48 is a LCM. 48 1 into 9 minus 6. It means again that is what is the balance? 3 by 48. This 3 by 48 work, again A will work one more day. So Sunday, Monday, Tuesday, Wednesday again A will work here. And next balance work is done by B. Minus 1 day work of B is what? 1 by 16. Take again, go to the LCM. LCM is 48. 48 by 1 into 3 minus 1. So now we can see 48 by 1 to 3, 16, 3 into 1, 3. 3 into 1, 3. Right. You will get 0 by 48. No work is left out here. So definitely again B also will take Thursday. He works Thursday. Right. And see, A will work for 4 days, B will work for 4 days, C will work for 3 days. Now see how many days? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days. Total work is done. Total work is done. Total work is 11 days. Total work is 10 days. And here see the total work will be finished in 10 days. Definitely this is not correct. This is wrong. Now let us see that statement 1. Work will be finished on Thursday. Wednesday, Thursday. Definitely this will suffice. Statement 1 is correct. Only 1 is correct. Option 2. Let's move on to the next question. Question number 34. Raj has 10 pairs of red. Raj has 10 pairs of red, 9 pairs of white and 8 pairs of black shoes in a box. If he randomly picks shoes one by one without replacement from the box to get a red pair of shoes to wear, what is the maximum number of attempts he has to make? Now let's see what is stored in the box. 10 pairs of red, like 10 pairs of red, 10 pairs of red, 10 pairs of red, and 9 pairs of white, 9 pairs of white and 8 pairs of black. So there are so many, and he picks shoes one by one. Total number of pairs we need to know. Total number of pairs are given. Total number of shoes, like 10 into 2, there are 20, and here 9 into 2 is 18. Here 8 into 2 is 16, the total number. So this is 14, 1, 2, 2, 3, 3, 2, 5, 54. 54 numbers are there, total shoes. Total number of shoes are 54 in the box. He picks one by one without replacement from the box to get a red pair. To get a red pair of shoes to wear, what is the maximum number of attempts? He is asking maximum number of attempts he has to make. Number of attempts he has to make to get a red pair. To get a red pair, he wants to take a red pair. How many attempts are required? Number of attempts. Number of attempts is, we wanted to know number. This is the question mark. Fine. Assuming total number of shoes are 54, because he picks one by one. Let us not take pairs instead of number of shoes. Number of shoes in the box is 54, and he wants to pick the red pair. So 2 red shoes are required to take, and number of attempts are required. Assuming that he keep picking one by one, he will not get red at all. So red may be blocked in the box. Only we are getting white and black. We are not getting red. It's not getting red at all. See that. There are shoes in the box. I want to pick 2 red shoes, but I don't get even till last. But how many? After how many shoes? The white is over, black is over. I will get 34. I will get 16. Here 20. What is the white? White is, how many are there? White is 18. White plus black. White plus black is 16. So total put together is 34. After 34 only, assuming that I'll start getting red. To get the red, I have to do one more attempt, that is 35. That is the. But only I'll get red. I need pair of red pair. Red pair is the 2. Again I have to go to another attempt. So that is 36. It means number of attempts are 36. Hence C is the right one. See the next question. In how many ways can a batsman score exactly 25 runs by scoring single, fours and sixes only, irrespective of the sequence of scoring shots? Either way, the combination is required. So how many combinations are possible? There are ones is there, and plus fours, this is the plus sixes. Here number of combinations are required. Number of combinations required. options are 18 combinations, 19 combinations, 20 combination, 21 combination. This is very lengthy process. It's very difficult to, but not difficult. It time consuming process. I think it is not advisable to solve the question also, subject to if availability of time. I don't think that is any CSAT paper getting extra time to do it. This is an additional work. This is a laborious job, but only we need to understand the pattern of working, that's all. So I may not solve the till last, but I'll show you how to solve it. You can do on your own. Let us not waste time here. I will have to discuss on concepts which are happening in the questions like that. Now see, this is not a concept based question. It is only lengthy process, time consuming process. So completely is a laborious job this is. Let's see that. See, one's combination, 4 combinations, 6, all 3 combinations are required. You have to write, because only the methodology I am telling you. If it is question is very small, then you can, if it is asked for 10 questions, 10 runs, 20 runs, 50 runs, okay, this is fine. And now you see 25 runs. The 1s are there, 4s are there, 6s are there. Only 4s and 6s you can do it very easily. But 1s is included, it's a laborious job. Let's see that is how it is possible. First let us start with the 6s. I'll see, just write it the 6s here. If you take 6 6s, 6 into 6, 36 runs. The total runs are 25. We need to run total runs. Total runs are 25. 6s, 6 into 6, 36 is not possible. We don't need at all. 6 into 5 6s, 6 into 5, 30. No, we don't require. 6 into 4. So 6s, number of 6s, you can 5 6s we don't want. Let us take 4 6s. 4 into 6. You will get what? 24 runs plus 1 single. You can take 1 single once. Once into 1. So you will get 25 runs. I am just trying to explain how we are supposed to solve it. But I am not doing it completely here. Anyway, 4 6s. Now let us come to 3 6s. 3 into 6. 3 into 6 is what? 18. 18 plus how many 1s are there? You can take 1s into 18. You can take 7, so 25, right? I will 2 6s. 2 into 6 is what? 12. Again, if you take 1s into 12 means 13, you can take this combinations, 25. And you take 1 6 and once 25. So this is, I have just taken 6s and 1s. Now let me take again 6 and 4s. 6s and 4s. This combination is over now. Another combination. So let us take 6s and 4s now. What is 4 6s, 3 6s, 2 6s, 1 6s, like that. Now let us take 4 6 plus 4s. Can we take that 4? Or you can take the 4s also. Number of 4s let us take. This is 6s combination. Let's take 4s. 4s. Like 6 4s. 6 into 4, 24 plus 1s is 1s into 1. Next 5 into 20. 5 into 20. 1s are 1s into 5. Again you can see that 25. And 4 4s, 16 plus into 12. 12 ones are 13. 1s into 13. So this is 25. And 2 4s, 8. 1s into 2 into 4 8. You can take 1s 17 you can take. So that's equal to 25. And 1 4 you can take. 1 4 plus 1s into 21 you need. So 21. So this much. Combination with 6 and 1s and 4 and 1s. See the time consuming, how the time is being consumed here. Huh? Yes. And see, now we can 6s and 1, 4s and 1. Now let us say 6s and 4s. 6s and 4s you can take. 6s and 4s. 6s and 4s. Right. If you take like 3 6s, 1 4 is not possible. 3 6s. Like 3 into 6, 18 plus. 18 plus how many? 3 into 6, 18 means 25. There are 7. 7 means you can put 1 4. 4 into 1. 4 plus 18 plus 4, 22. Once into 3. This is equals to 25. You can see that is how much workspace is required, how much time is being consumed here. Now let us see. We have taken 3 6s. Let us come to 2 6s here. 2 6s. So 12. There are 4 into 3 4s plus 12 plus 12 is 24. You can take once into 1. This is 25. Now, and see here once. Let us take 1 6 here. 1 6 plus 25 minus 6 is 19. 19 means there are 4 4s. 6 plus 16 plus 6 22. And once what is the once required here into 3. So this is 25. This is another one. But I over. Now let us start with the 4s. 4s and 6s were 4s. How many 4s? This already you have taken. See the number of combinations here. How many are there? 4. 1, 2, 3, 4, 5, 6. 6. Here 4. These are 4 combinations. This is something like the 6 combinations. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And here you can take 3 combinations. Like 13 combinations. Already 13 is there. Now what is left out here? That we need to check that. Now only once you have to take. Only once I am talking. Now once singles combination take. So once 1 into 25 is possible. So you will get 25. And if you take like ones are 25. Ones are 25. And ones are 24. Can you take like that here somewhere? 24? No, it's not possible. 23 is not possible because 4 we need to do. Like 22. Ones are 22. No. 21, like 21 into 1, okay, 21 into 1, 21, 4 runs, that's 1 4, 4 into 1 you can take. So this is another 25 here. And see now let us come to what is that 26. Let us come to 19 ones. 19 ones plus 1 6 you can take. So 6 into 1. So this is again 25. Right. So how many are there? 4 plus 10. 10, 13. 13 plus 13, 16. 18 you can take here. 18 ones. 18 into 1. 18 into 1. 18 runs. Plus 1 6. 6 into 1. 1. Plus ones into 1. So this is another combination to 25. And see the 17 ones. Can we see 17 ones anywhere here? That should not be repeated. That is 17 ones are there. We have taken 17. 17 means 8. 17 plus 6, 23. Okay. You can take a different combination. 17 into 1 plus you can take 1 6. 6 into 1, 17, 23 and ones are into 23, 25, right. This is 17, right. How many are combinations are there? 1, 2, 3, 4, 5. 5 is there. Total is what? 4 plus 6, 10, 10 plus 3, 13, 13 plus 5, 18. So option A. Option A. So this is the working. I would advise everyone, this is not advisable for any aspirant to do that. But only thing is, I would suggest that at least you can work on it. Only thing is, anyway exam is over, you may try next year, fine. But if this question is asked, the number of combination must be written there. You should practice it. Only for our benefit's sake, that's all. See the question number 36, there are 4 letters and 4 envelopes. 4 letters and 4 envelopes. And exactly 1 letter is to be put in 1 envelope with the correct address. With the correct address. If the letters are randomly inserted into the envelopes, then consider the following statements. Fine. What is the content in the question? There are 4 letters and 4 envelopes. Number of letters. Number of letters are 4. Number of envelopes is 4. Number of letters are 4. Number of envelopes are 4. That part is 4. 1 letter is to be put in exactly 1 envelope. 1 letter exactly in 1 envelope. See, this is the thing. 1 letter exactly in 1 envelope. It means 4 letters will be accommodated, will be put in 4 envelopes with the correct address, and that to be for correct address. So correct address, right. If the letters here, if the letters are randomly inserted into the envelopes, then consider the following statements. Right. Now we have to read the statements. What are the letters, number of envelopes? Now let us take here. Envelope 1, envelope 2, envelope 3, envelope 4. So letters are, you can take A, B, C, D. Envelope 1, envelope 2, envelope 3, envelope 4. Letters are A, B, C, D. These are the letters. It is possible that exactly 1 letter goes into an incorrect envelope. It is possible. There is a possibility. It said there is possibility. There may be an error. Actually, it is supposed to get into the right address. Right. But it is possible that exactly says, word exactly, it means only 1 letter. 1 letter goes into an incorrect envelope. Okay. There is a possibility that exactly 1 letter goes into an incorrect envelope. Still, we don't get the right clue here. Let us come to the second statement. There are only 6 ways in which only 2 letters can go into the correct envelope. There are only 6 ways. There are only 6 ways in which only 2 letters can go into the correct envelope. So how it is possible this is? See, it means 1 letters go, if assigned like that, envelope is the right address. Envelope 1, envelope 2, envelope 3, envelope 4. Assuming that is envelope 1, it must be for letter A. This must be for B. This must be for C. This must be for D. 1 letter goes into the wrong. Let us take that is A goes to the wrong envelope. A goes to the wrong envelope. This is supposed to be. But the possibility is what? A may go. So here, there may be A. Here also A. There is a possibility A. It means there is a possibility of getting envelope A goes here. Either maybe B, C, D instead of E1. It is possible that 1 letter goes into an incorrect envelope. Incorrect envelope thus maybe go into the 3 envelopes. or like that. So there are only 6 ways in which 2 letters can go into the correct envelope. But we do not have sufficient information to arrive to conclusion. Why? Because the A is supposed to be put in envelope 1. The A may get into A may be put into envelope 2 or envelope 3 or envelope 4. It is not known exactly. There are only 6 ways in which 2 letters can go into the correct envelopes. But how? We do not know, because some insufficient data is provided in the question. So we can't say, even by taking 2 statements, it is not possible to arrive to the decision conclusion. So we can say neither 1 nor 2. Neither 1 nor 2. Right. Let us try to solve another question. Question number 45 from B series. Consider the sequence ABC dash dash ABC dash DA BB CD dash ABCD that follows a certain pattern. Which one of the following completes the sequence? Now let us write here. Right. See, how many are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are total number of letters in the sequence is 20. So 20 can be equated with 4 into 5 or 5 into 4. Like 4 letter groups is 5, 5 letter groups are 4. Let us take 4 letters. If you take 4 letter, ABCD is here, like ABCD1, but ABCD is not there. See that there are actually 2, 3, 4, 5, 6 letters. ABCD is okay here. If you take 4 letters from here, ABCD is not possible. Definitely this is not 4 letter groups. Let us take 5 letter groups. 5 letter groups 1, 4, like 5, 3, 4, 5, 4, 5. Now we can see here the last letters are ABCD. Okay, last letters are ABCD. Here you can see there are 5 letters. This is the direct clue here. This is the direct clue. ABBCD. ABBCD. It means last letter is D here. And see, the last letter is D. And see, now the last letter is D. And last letter may be D. What is the last letter D? You can see here. Still you don't get anything here. See, the last letter is D. Here the last letter is D. Here the last letter D. Okay. Considering this must be the last letter D. And it means first letter, second letter D we can see here. Right. Option B and option C. Option A we don't need and this is ruled out. We can shortlist and arrive to the conclusion between B and D. Let's see B and D. Now A, B, C. Now here you can say like A, B. If you see A, B, C, D. If thinking this is D, let us see A, B, C, C, D. A, B, C, C, D. A, B, B, C, D. I think some there is a problem here. Like D, D. Let us take D, D. Okay. A, B, C, D, D. A, B, C, D. Last letter is twice. A, B, C, D, D. A, B, C, like A, B, C, okay, you can take C, C it is here, right, A, B, C, D, D, A, B, C, C, D, A, B, B, C, D, A, B, C, D, definitely option D is the right one. Question number 47. Consider the following statements in respect of 5 candidates P, Q or S, T. Candidates are what? P, Q or S, T. the two statements are true and one statement is false. Here there are three statements. Two statements are true, one statement is false. Statement 1, this is actually statement 1, right? Statement 2, statement 3. Okay. Statement 1 says that statement 1 says that P and Q was selected for the job. One of P and Q was selected. One of P and Q. One of P and Q. One of P and Q. P and Q was selected means here either P or Q. Either P or Q. One person, one of the two people, right? And statement 2 says what? Statement 2, at least one of R and S was selected for the job. Because this is true. This is false and this is true. Because there is a missing letters that and no, yeah, it is written here. It is a true, is false, this is true. First statement is true, this is true. Second statement is false. Third statement is true. Right. Now second statement is right. At least one of R and S was selected for the job. But it is a false statement. It's a false. Not at least. At most, you can say. At most. At most, you can, instead of telling at least, you can say this is at most. At most. At most, you can take. Okay. At most, of R and S was selected. At most, one of R and S. One of R and S. At most, one of R and S. Either or yes. Okay, right. Now statement 3, at most 2 of, statement 3, 2 of R, S and T. In the sense what? At most 2 of R, S and T. Only 2 people out of 3 people. Maybe combination is what? R, S or R, T or EST. This is a combination. Fine. Now let us come to the questions. At least 4 were selected for the job. At least 4 were selected. Minimum 4. Right. Maximum 5 also. Minimum 4. Where do you get possibility here? In the statement we say either P or Q. It means only there is only one person is possible here. And here's at most either R or S, only one person is possibility here. And here 2 of R and R, S and T. Here R, S, R, S and R, S, R, T, R, S, T. It means definitely we don't want to take this sound also. Okay, we don't need, because R or S both are combinations are here. It means 2 R, S, it means only 2 people will get. So let us not take this. 2. It means 4 were selected. Only 3 will be the possibility. So this is not correct. And statement 2. S was selected for the job. S was selected for the job. S was selected. How do we say S? P or Q? This is okay. S, R or S? We don't know. R, S, R, T or ST. Even ST is a possibility. Like RT is also possibility here. So yes, we cannot say, we can't determine that. We can't come to the conclusion, and this is also not possible. So neither one nor 2. Option D. Fine. Let us try to solve another question. Question number 48. Let P, Q, R, S and T be 5 statements. There are 5 statements are given. P, Q, R, S, T. There are 5. If P is true, then P, Q and S is true. P is true. It means P is true. If P is true, then Q and S are true. So this is statement. If R and S are true, if R and S are true, R and S are true, then T is false. T is false. See now here. This is the information can be derived from the statements given. Let's see the question statement. If there are two statements, if T is true, at least one of P and R must be false. Here T is false, then R and S are true. If the T is false, R and S are true. If the T is true, one of P and R must be false. One of P and R must be false. Here you can see P equals to Q and S. This is Q and S are true. And here R and S are true, T is false. When definitely S cannot be taken. S is true. Then S is true. Okay. Now when T is false, then equal to either P and R, either P or R is a false, either false. So definitely one is right. Now second one, if Q is true, then P is true. See, if Q is true, if the P is true, then Q and S are true. When Q is true, P is also true. When Q is true, then P is also true. Right. So this is also right. So both 1 and 2 will follow.